Hey guys, today we're going to be talking about Newton's law of gravitation, which is represented by this equation here that we will be using later on. But first, we're going to be working with this example problem, which basically says that we have a mass of 100 kilograms. We're going to be comparing the weight difference at sea level versus the top of the tallest building in the world, the Burj Khalifa. So, first step in this problem is we're going to find our weight at sea level. Now we can easily find this if we remember that weight equals our force, which equals our mass times acceleration, which we're just going to get 981 newtons, 781 newtons. But when we solve this problem all out, we're going to find that the force difference between the force at sea level and the force at the top of the Burj Khalifa is going to be very small, and this is not a exact enough number for us to work with. So we're going to use this equation, which is Newton's law of gravitation. Basically says that our force at sea level equals the gravitational constant times our mass of Earth times our mass, all divided by the distance squared. In our case, the distance is the radius of the Earth. So we're first going to start off with what our knowns are. So G equals the gravitational constant, like I said earlier, and that is 6.67 times 10 to the negative 11 newtons times meters squared over kilograms squared. Next, our mass of Earth, which is 5.97 times 10 to the 24 kilograms. And then our mass, which is 100 kilograms from the problem. And then the radius of Earth, which is 6.3781 times 10 to the 6 meters. Guys, so then we plug in all of our numbers here into our equation, plug that in your calculator. We're going to get our force at sea level equals 981.34406 newtons. A lot more accurate than our previous number, 981 newtons. And this is going to help us find our weight at the top of Burj Khalifa, which Kelly will be walking through next.
Cool. Now that we've found the weight of our weight at sea level, we're going to find our weight at the top of the Burj Khalifa. So to do that, we have our original equation, except this time we are going to add the height of the Burj Khalifa to the radius. And so the reason we're going to do that is because the radius of the Earth is that, but now we are on top of a very tall building, so we have to include that as well to get a more precise answer. So we already have all of these. All of these are constants except for our mass and the height. So we're gonna replug all of that, and our height over here is listed at 828 meters. You can see there. And yeah, so we're gonna.
Yo.
Okay, so we found our new weight on top of the building, and now we're going to compare our weight on top of the building versus our weight at sea level, which is right here, by doing delta F between the two answers we got, and that comes out to 0.25507 newtons. This makes sense in theory because really when we're adding to the denominator of this equation, as you add to the denominator but keep your numerator constant, your number will become smaller. And it also makes sense since we're getting farther away from the core of the Earth, the gravitational force will become weaker as our distance grows.